In case you want to connect with us on Azure Singapore and you want to contact the organizers using the contact details provided here. We have been running this meetup for quite a few years, and recently we have had some of these interesting sessions. If you want to see the recording of these sessions, these are available on our YouTube channel as well. Coming to today, we have Brendan Burns, who is the Corporate Vice President in Microsoft. More than that, I think whoever knows about Kubernetes knows him as the co-creator of Kubernetes. He's also a distinguished author, and I personally find his series on YouTube about the Kubernetes basics quite helpful. I've learned a lot from this, and I would recommend that if you're not seeing this, how to start IoT projects. And in case you don't know, we also have a YouTube channel where you can find all these recordings, not just the Azure Singapore, but also the other recordings which are run by our fellow MVP colleagues. So with that, I would like to hand it over to Brandon. Just keep in mind these are the some housekeeping rules we have. So while the session is on, please keep yourself from mute. If you have any questions, please raise question using the raise hand feature of Teams. If you are joining us from YouTube or Facebook, you can raise the question in the chat window and we'll bring it back to the session here. This session is being recorded, and thanks for joining us. Over to you.
Great, thank you. All right, do you see that now?
Yes, I can see it.
All right, perfect. Presentation. All right, cool. Thank you for joining me and giving me the opportunity to present today. It's one of the sort of unexpected benefits of the pandemic that we can do these sorts of virtual events across the internet. So I'm really pleased to be here and happy to get this chance to talk to you. I wanted to start, this is a repeat, I guess, of a talk that I gave at .NET a while back. And it's about really the philosophy of microservices. So, there's a lot of great material out there on Kubernetes and technologies and things like that. But for this talk, I really wanted to talk more about the philosophy, more about how to think about these things and why these things are important. And so I'll begin with the question, why do I care about microservices? But in reality, I think actually that's the wrong question to ask. I don't actually, I hope at some level that you don't care about why I care about microservices, but rather, because at the end of the day, all of these places that we're living, all of this technology that we're building upon, is to serve some role that you have to take. It's not about what I think is important. It's not about what Microsoft thinks is important. It's not about what anyone really other than you and your team thinks is important. And so hopefully throughout this talk, we're going to focus on not sort of telling you what you should do, but hopefully convincing you as to why you should care and why you should do. But of course, in fact, I actually don't care about it. And you shouldn't do. And so with that, I'll give you back to 50 minutes anytime. No, I'm kidding actually about that, but I really believe that you shouldn't care about microservices, because at the end of the day, a choice like microservices it's just a technology choice. It's like choosing to use a particular programming language, or choosing to These are all technology choices. Technology, for its own sake, is not very useful. And in fact, I've often said to people who are talking to them, what are you unhappy with? Because as we start this conversation, if you're not unhappy with anything you're doing currently, don't change. There's no reason to. If it isn't broken, don't go around fixing it. And so I want people to really be thinking about not the technology choices that they make, but rather the things that are important to them that lead to technology choices, and how technology can make the things that are important to them easier, faster, and more reliable. So what are the things that you care about? What are the things that you care about? I think that first and foremost you care about your product. You care about the thing that you're building. You have this vision, this idea, this notion of what should happen, what should be changed in the world. And you want to bring that into reality. In some ways, this is the best part of software development. The best part of being involved in technology is that opportunity to take an idea and craft it into a thing that people can use, and a thing that people can, sort of not quite feel, of course, because it's software, but to interact with, and the ability to take that vision and make a reality with the benefits. It's something that we all fundamentally care about. It's certainly what drew me to engineering in the first place. That is kind of magical, actually, to be able to go from vision to reality. So I hope you care about your product. I hope you also care about your users, because at the end of the day, it's great to have vision, an idea, and bring it to bear and see it out in the world. But if nobody else finds it useful, and if nobody else likes to use it, well, it's probably not as great a thing. I mean, it's fun to build things no matter what, I guess. But it's especially fun to build things that other people find useful. That's one of the most sort of amazing and humbling and awesome things that I've had the opportunity to do over the past few years is build this software and watch it spread around the world. Watch people come to know this idea and the product that we had built as a community, and really come to say nice things about it and really see their lives changed by it. That's amazing. So I hope that, in addition to caring about the product, and in addition to caring about bringing your idea out into the world, you also care about the people who take that idea and take that product and go forward with it and make it a part of their lives. I hope you care about your team. Most software that you guys do, like I know all software is built by a team. It's not built by individuals with long past the days sit down and they write a computer and write a computer operating system or to write a word processor. Software development is a team sport. It has been for many, many years. And like any team, I hope you care about the people you work with. At the end of the day, spend a lot of time with it, so much time with it, just as you can with it and more. And so I hope that time spent is caring about your team as well. And so now that we have sort of gone through the things that I think you care about, I want to transition to say, well, what does microservices have to do with it? And the first thing I think is important to note is that this whole microservices thing is something that has happened before. It has had different names, and it has had different moments. But I would argue from compilers to object-oriented programming to service-oriented architecture, very buzzwordy thing in the early 2000s, we're repeatedly kind of coming up with new ideas and then expressing new ways of putting software together. And it's fundamentally because building software is hard. Although actually I would take a step back from this and I would actually say building software is actually not hard at all. I think it takes some time and experience to learn how to program and to learn how to take your ideas and design them and turn them into something that other people can use. But with practice and enough experience experience, building software is actually not that hard. What's really hard is building software. And as good as I have gotten at writing code and building software, it has taken much longer for me to get good at helping teams build software. And I still have problems. Right? I don't really have a lot of problems writing software these days. But I still have problems with teams. Right? I still have problems getting teams to coordinate, getting teams to execute, getting different voices to be heard, getting teams to rely on one another, getting teams to not reinvent the wheel and rebuild everything every time. So I think that fundamentally, in software engineering, discipline fundamentally people trying to resolve this problem. That each individual writing code is relatively straightforward, but pulling people together as a team is a real challenge. And so fundamentally, microservices, they're not about technology, they're not about software, they're not about Kubernetes and containers and anything else like that. Microservices are about scaling teams. Because it turns out that this is a hard problem. People will talk about naming and off by one error, and there are other hard problems in computer science, but scaling is actually one of the hardest things. And this fundamentally comes down to the fact that the ideal team size is about 5 to 6 people. And I think anybody can be involved in any kind of project, whether it's software or anything else, or investment. It's just you by yourself with your own team with always way more work to get done than the hands to do the work. So it's always nice to add a couple of people. They help, they offer advice, they can take on some of the work, you go faster. But at about 5 or 6, the act of coordinating is a challenge. And so we step through sort of all the reasons why the ideal team size is 5 to 6 people. So for starters, you can also sit in one room. I realize we don't really sit in rooms anymore. I think we'll go back to sitting in rooms someday. But metaphorically, at least, you can sit in a single room and experience each other on a day-to-day basis and talk to each other and know about, it is sick, but just got a new car, who's getting married this week, something else like that. You know each other at that scale. And that's really important for making software work. I think the other thing is that the amount of code output that 5 to 6 people do is still pretty understandable, right? You can't reach a place where there's areas in your space that you don't have any experience with 5 to 6 people moving out code. More or less everybody's involved in all the code. More or less everybody's involved in it. Especially so for sure. But the team knows and understands how to code and past that, it's not happening. And there's tons and tons of ways of Kubernetes code base that I have to relearn every time I want to go and make a change, or every time I want to understand why this is there, I have to go and relearn it. It's expensive, it takes time, sometimes it's very, very frustrating. And so, in smaller teams, that doesn't happen. So it's a big team. Almost as important, everybody on the team understands the product. We understand what we're all trying to build together. And there aren't really a lot of people who think about that. There isn't sort of like, I'm the team that does that activity, and they're the team that does the back end, and they're the team that does the game. Sort of like, no, it's like everybody's all working on the same thing. And that sort of common vision really results in a much higher sort of alignment, less discussions, less disagreements, more clarity in general about how this is going. Similarly, you understand each other's styles of work. You're constantly working with each other. You understand that that person is particular for style, and then it's really hard to do here. So I'm going to go to that when I'm uncertain in my code, and I want to that person is relaxed, I'll go to them and I really just get the code merged. You understand how you work, you understand how to work with each other at that small scale. And I think this is almost the most important one, which is that you all feel like you're on the same team. And it seems sort of, solipsistic to say, this really feels like you're all on the same team. But the truth is that, once you get past 5 or 6 people, what you find is that suddenly different motivations come into play, and different kind of agendas start creeping in, and people start thinking about promotion, or they're thinking about their product, or they're thinking about how can I become a manager rather than what's the right technical. And all of those little variations of not quite being a team, again, lead to friction, lead to discussions where you're not really talking about the subject of the discussion. This person really wants that code designed that way because they want to create a subject so they can become a manager. But they can't really say that. So it's, I think when you get past a certain scale, the scale itself starts making it less likely that you don't feel like friends, even if broadly speaking you are. And so at this point, I think you probably will well, of course, let's just all build 5 to 6 person teams and happily go off into the software development nirvana. But of course, that isn't the way it works. And, Microsoft stopped being a company of 5 to 6 people, many decades ago, and it has every other major international company. And that's for one very important reason, which is that most projects eventually require an army. And so this is in some ways the fundamental challenge at the heart of computer science. On one hand, it just took a long time before convincing you that 5 to 6 teams are the ideal team size. And now, actually, I'm saying, well, if you want to build Windows, or you want to build Kubernetes, or you want to build Linux, or you want to build any project at a scale, you need a lot of people, thousands of people, tens of thousands of people, probably over the last 30 years. And so we have this challenge, which is we want to maintain small team sizes, but we also really need to have large teams to get scale. But the trouble with that is that army is not agile, right? So if you build your army and you keep scaling, you're going to end up with a giant war, but it's going to be incredibly hard to make it happen. And this is what leads to things like the Windows dilemma, and all sorts of other reasons why technology companies seem to have this inevitable story of growth, and then stagnation, and then decline. And then sometimes reverse. It's fundamentally continue to struggle with this blend between 5 to 6 teams on the side projects. And the other challenge we have, of course, is that most engineers, and most engineers who I've ever met, are really bad at following orders, right? And so not only do you have this army of people who aren't agile, you've got an army of people where everybody kind of wants to make their own decisions. And that's not traditionally how armies are organized. Armies tend to be very rigid and hierarchical. So if you want to make a large group of people, function efficiently, one way to do that is hierarchical command, right? Generals and then lieutenants and then privates. But in engineering, it just doesn't work, right? Because no engineer wants to be, four-letter hierarchical staff. They want to have a independence. And in fact, I would argue that because our industry changes so rapidly, and knowledge of the areas and economies are really important to success, we're actually more successful if we decentralize. We're actually more successful if we decentralize. So what do we do? I understand I have a little weird stress because I sort of laid out a lot of problems, a lot of reasons why you want small teams, a lot of reasons why small teams don't work, a lot of reasons why you might want big teams, and a lot of reasons why big teams don't work. So the question is, what do we do? It brings me back to the original topic, which I wanted to talk, which is Microservices, right? So the good news also one of the good news that saves us from this dilemma is that software is modular. So when it comes time to build our software, the really good thing about it is that we created, by force of necessity, created things like objects, object-oriented programming, and APIs, and interfaces that allow us to be modular. So we can build a bunch of little pieces and have those little pieces fit together to form something much bigger. Right? Think about the Great Wall of China. It's just a bunch of bricks at the end of the day. And someone made those bricks one at a time, and someone stacked those bricks one at a time. That really is in some ways a metaphor for all of the software that we have. We're fortunate that we can identify little pieces and then assemble those pieces into a much grander thing. So what pieces do we need? Right? The software is modular, and we're going to go build these pieces. What are the various components that we need in order to build up these pieces? I think one of the most interesting pieces of this, when we think about the pieces that we need, because all of the pieces that we don't have in any given application, there's some amount of commonality in those pieces, right? But of course, there's other differences as well. I think that we plan to scale our application, right? Like when we approach an application, we say, okay, I'm not going to run the web server and the database in the same container, because the container is my unit of scaling, and if I have to scale out the web server, if I package my container this way, I'm going to end up with 2 copies of the database. And obviously that's no good, right? Because now suddenly I have different data streams, which is bad. So when we think about designing our system, we separate things apart on the axis of the scaling. So we separate the web server out into its own container, the database out into its own container, so that when it comes to scale, we can scale up that web service without having to scale the database. Right? And in fact, we're going to scale the database by making the machine bigger, not by replicating our application. So we think a lot as engineers about how do we scale our applications, how do we build efficient algorithms, how do we build systems that scale. I think what we spend a lot less time thinking about is how we scale our teams. Right? And so I would argue that planning to scale is as much about designing the architecture right as understanding how your teams are going to grow. Because one of the reasons why monoliths are challenging isn't just that they're challenging to scale the software, they're also very challenging to scale the team. Because if everybody's building the same piece of software, building the same code that all goes into one giant binary at the end of the day, well, you've inherited 100 or 1,000 new codes. You've inherited 100 or 1,000 new processes. You've inherited a ton of baggage that comes from all of the different cooks with binary software. And it's not a very scalable way to build teams. Those teams are constantly discussing with each other how much data are you using, how much data am I using. They're going to constantly have to be working together to roll out and roll back the software. I've got this code, well, how bad is it? Because I've got this feature that the user needs, and if we roll back, I will lose that feature. All of these discussions add friction, add possibility, and ultimately make your teams less agile and less efficient. So I think that it's important to be thinking not just about how we scale to meet demand, not just how we scale to meet customers, but also how we scale, how we build our architectures to scale up. And fundamentally, I guess that's what microservices are trying to do. How do we do this? Well, I think practically the transformation that has happened partially through Solo and service-oriented architecture, but absolutely through microservices and the explosion of modern single-page web apps, is that all products effectively now are using APIs. And the reason for this really is both because it's more scalable, because it's the first scaling aspect of scaling our team, and then we have a back-end team and a front-end team. But also because the demands of the user are such that it is scalable to different platforms. So I can have an Android team and an iOS team and a web team and maybe a mobile web team, maybe a desktop team, and then obviously a backend API team. And because I'm thinking APIs, REST, gRPC, the individual APIs themselves are also just for scaling up. I can separate out different APIs and different and so by taking this approach, if every single product you ever want to build is a UX on top of an API, and having that first formal separation between the UX and the API, you've taken your first step down the road towards designing a software system with them and have a scalable tool. So then how do we do this? Like, how do we actually take that design philosophy and turn it into I think the first and most important step is to define boundaries. It may seem obvious, but there's this great quote that says, good pencils make good movement. And it's important, defense is an important thing, not just because you know what the boundaries areas are, but also because it tells you where you don't have to play. I'm going to care about what's happening on my side of the fence. I'm going to not care as much about what's happening on your side of the fence. And that sort of not my monkey, not my circus line, that delineation of where I delegate and where I decide is incredibly important. Because now suddenly I know what I'm supposed to be responsible for, and I know what I can ignore. And that ability to ignore things and have other people ignore my things is one of the most important things to start seeing. I think the other piece of defining that boundary is this idea of decoupling. Right? So the tighter we're all bound together, the more accidents can happen. I don't know how many people have ever tried to watch someone back a boat down a boat ramp, or back a tractor trailer around a corner, or any other kind of system where a truck is towing a load. But it can be comical. In fact, I know people who've gone to the boat ramp where people back their boats down near my house, and as amusement to watch people try and do this, because it's very hard to do for amateurs. And the reason that it's hard to do is because of the pivot point between the truck and the trailer. And you get to a situation where pushing the truck in one direction pushes the trailer in a completely different direction. That coupling between the systems makes it hard to manage. And apologies, it's playing. And that sort of coupling in general is what leads to outages for systems, right? Because nobody wakes up in the morning and thinks, hey, I'm going to go break production today. What happens is they push a change and there's some unanticipated consequence. That unanticipated consequence comes from the fact that there was a coupling in the system that people didn't understand, right? So if we have the ability to do anything beyond defined boundaries, it's decoupling our teams and our APIs from one another. Similarly, I think we need to empower our teams, right? We can't be in the business of telling them what to do, in terms of telling them, you know, oh, this is the way you have to implement it. This is the programming language you have to choose. Although we'll get to those sorts of choices later on, because there are trade-offs. But we have to give the teams the freedom to design their system and not interfere. If an API is delivering on its SLA, I can't go to that team and ask them how they designed it. Well, I can ask them if I'm curious, but I can't try and get them to change it, right? It's no longer my problem. I've asked for them to deliver a certain amount of uptime. If they're delivering it, they're empowered to do their thing. But as I mentioned, there are choices like programming language and others that have some implications. And so while it's important to provide all these boundaries, provide all this autonomy, provide all this empowerment, there's also a degree to which we have to strive for commonality too. It can't just be, and maybe this is the theme of this talk, is that there are constantly trade-offs. We can't just all be rogue individual teams doing our own thing. We can't just be an army monolithically headed all in the same direction. We have to find that balance, because when we think about it, there has to be ground rules for our APIs, right? There has to be some amount of consistency, or else the people who are building the UX on top of these APIs are going to be pulling their hair out. One of the most important ones is the idea of a deprecation policy. When you use a cloud, when you use Azure, we have a 3-year deprecation policy. It means any API that you use that is generally available, it will not go away for at least 3 years after we tell you that it's going to go away. Right. So this gives you the certainty and the confidence that you need to build on top of these APIs. And it's not even for deprecation policies aren't just for external facing APIs. They should be something that is taken by a company overall for all of their teams. It doesn't necessarily have to be 3 years. It might be 3 months. But having every team delivering an API have an explicit deprecation policy. And have a formalism around that deprecation is a really important part of ensuring that teams can actually successfully do this decoupling and can successfully establish trust. Because if you take your API and you break it every week and you don't tell me about it, and I have to rewrite my software every week and it slows me down, I'm not going to trust you. Right? So we have to have a consistent deprecation policy in order to build the kind of freedom and empowerment that we advocated for on the other side. We need to have documentation, right? I mean, if we want to decouple and we want people to not bother us, we want people to not ask us questions, and we want to have that 5 to 6 person agile team, well, one of the costs that we pay is writing good documentation, helping people self-service to explain to them how to use our APIs. If we don't do this, you cannot get upset when people come into your mailing lists or into your offices and ask you how to use stuff, ask you how things work, because you didn't tell them, you didn't give them a chance to learn. This is another one that I think is overlooked way too often. Documentation is often overlooked. Quality of service is another. If you have an internal API, or with an external API, it's a little bit more obvious that you need to have quality of service, although even then, people don't necessarily formally state it. How many of the APIs have we built where someone says, this is what my latency is at the 99th percentile. This is what my reliability is overall. And I think it's even worse for internal APIs, right? So for internal APIs, oftentimes there are no quality service metrics at all and no quality service promises. And you can, if you think about it, that's just crazy, because how can I build on top of an API if I don't even understand what level of reliability it's going to deliver? And how can I hold someone accountable for the delivery of that API if they've never promised me a certain quality of service? One of the worst places for a customer to end up, in my experience, is in between two teams who have a disagreement about whose fault it is. Because they will just, lob the issue back and forth for weeks, trying to get the blame to stick to the other team. Obviously, that's pretty dysfunctional, but I've seen it happen more times than I would like to admit. And part of the reason for it is because if there's not a clean contract between the teams, if there's not a clean definition of the service level guarantees that each team was delivering to the other, as well as obviously monitoring to validate those service level guarantees, then obviously people are going to, there's the ability to toss the issue back and forth, right? There's no, but if there is a quality of service guarantee and there is monitoring that shows that a team breached and their latency used to be 2 seconds and their latency is now 10 seconds at the 99th, well, then it becomes very clear whose problem it is. And it becomes very clear that which team needs to fix something or figure out what's going on. Right, so quality of service on all of your APIs, formally stated, measured, and monitored, is an incredibly important part of not just delivering a product to the customer, but actually building scalable teams. I think this is one that also goes overlooked or short-circuited through, and that is that all of your teams communicate to each other via APIs. Right, they can seem sort of heavyweight. Why should I have to go use, a Swagger API and a generated client to talk to this other team that's right next door to me? I just want to get into their code and use their SDK, use a chunk of their code and make the raw web call. Well, the minute you do that, the minute you remove the formalism, the minute you remove the barriers between the teams, you've coupled those teams together. And just as I mentioned earlier about how coupling leads to outages, if you don't have your teams talk with the same level of formalism that you expect of your customers, you're going to inevitably sort of glom all of your services together in unexpected ways and in ways that make it much, much harder to deliver a reliable service. This is another important piece that I mentioned earlier, which is that if we do establish these SLAs, we do establish quality of service, as long as the team is meeting, we don't ask any questions, right? And we don't tell any questions, and we don't tell people about the implementation details. This is kind of like leaky abstractions, right? So even as we think about our microservices and we think about defining APIs, if our APIs are leaky and the abstractions that they put forth are leaked to the user, to the users of those APIs, either via explicit conversations or introspection, again, we're coupling our systems together, and we're tightening the dependencies that make it much, much harder for a team to iterate and move on. This is another really important one, I think, that happens. Again, very few teams do this properly. This idea that if I'm delivering an API, I should trust no one, right? I should assume that even the team down the hall from me is a potential attacker ready to do a denial of service on my system, right? If you don't do this, then sooner or later, one of those teams down the hall will actually turn into an attacker who is doing a denial of service on your system. And they won't do it maliciously. They won't do it on purpose. It's very rare that someone, attacks your service because they are a malicious user. They're going to do it accidentally, right? They're going to launch some test job that was intended to just be a bunch of unit tests that is going to hammer a production service or whatever. They're going to fat finger something, and instead of running 10 replicas, they're going to run 10,000 replicas. It is practically guaranteed that any consumer of a microservice is sooner or later going to be turned into a malicious user of that microservice. And if you don't have rate limiting in place, if you don't have strong authorization and authentication, you're going to have no idea where it's coming from. You're not even necessarily going to be able to tell the difference between, is this user traffic, is this internal user traffic, external user traffic, what service is sending it, right? So if you adopt a stance of trusting no one, not only will you build a more secure system, that's obvious, you'll actually also build a more reliable system, because when the inevitable, accidental overloads happen, you'll be in a place where you can deflect them. This is kind of like what I mentioned earlier about not leaking your abstraction details, but it kind of has more to do with how you build for yourself, right? Which is that if you're going to build some admin portal, you're going to build some backdoor, you got to go through your own APIs. Can't build backdoor APIs. Can't build special hooks that allow you to do it doesn't work that well. Again, you're leading to this coupling. You're actually also going to lead to bad APIs because you won't be practicing, you won't be using your APIs on the regular. And so you have to insist on this kind of discipline. And it's something that we were actually guilty of early on in Kubernetes, of not necessarily hewing to this discipline. We had a couple of instances where people went into storage directly. And I've seen more problems in general by teams who, instead of going through the formal APIs, went directly to the storage layer, went directly to the database, directly to Cosmos DB, didn't go through the API layer like the end user did. I've seen more problems from that than anything else, because again, that storage layer can be a point of coupling. The API can be iterated. The API can have different revisions. The storage layer, much, much harder to iterate it, right? So if people go in and talk to the storage layer directly, you are tightly coupling all of those different microservices together, and all of those benefits of agility of that 5 to 6 person team have been lost, right? And so, again, trying to maintain those small agile teams as a way of scaling your product means you have to ensure that all of those teams are separated and isolated from one another. Okay, but this is sort of the theme of the show, is that there's all of these rules for APIs, and we're trying to emphasize autonomy, but at the same time, there's a lot of consistency that we need to have as well. Because I think one of the things you'll see that happens is if you allow everybody to make their own choices, you'll end up with a wild heterogeneity of choices. And while that can seem initially like a really good thing, and it can be a good thing to have some amount of choice, it also actually really hinders your teams. Because getting back again to the fact that software development is a human problem, um, humans are going to want to switch teams. Humans are going to want to, for reasons of career or personality or just boredom, they're going to want to switch teams. And if every team in your company uses a different programming language, uses a different style, their knowledge isn't going to transfer. You're going to have people. So we talk about people who are tightly coupled. They're going to have people who are tightly coupled to their teams, and as a result, if they're unhappy and they want to move, they're going to leave. And nothing destroys the agility of a team more than having people leave, right? Because they carry with them knowledge, they carry with them experience. You have to train up a new person if you can even find that person. So having some portability of skills across all of your teams, despite implementing all of these very highly separated, trust no one microservices, is really important. And I would argue that that means that you restrict the programming languages to maybe one or two in your application. Maybe a front end language and a couple of back end languages, a scripting language, a couple of back end languages, front end language, but keep it under control. Don't just go chasing after the latest flavor of the month. Don't go do, Java and then Groovy and then Kotlin and then who knows what else, right? Again, as we mentioned earlier, if it's working for you, stick with it. And consistency in language is actually important from a career perspective for people in all of your teams. Similarly, don't choose, a billion different file formats, right? I've seen all of these problems that arise from the fact that the team that was interested in data languages created a new data language every 6 months. And so whatever happened to be the latest, greatest thing was used for that system. And then it becomes a configuration language that you have to remember for forever. And if you build new services every 6 months, you're rapidly going to end up with, tens of different configuration languages out there, which makes the tooling worse, which makes the learning worse, which in general, XML is not great, but if 95% of your company is already using XML for configuration, I think you should keep using XML, right? There's no good, heterogeneity is a killer in these kinds of systems. Similarly, out on the front end, right? The frameworks that you're using, you need to choose one front end framework and stick with it, even if it's PHP and it's still 2020. You have to establish this core infrastructure, right? If you don't do this, the heterogeneity that we were advocating for, because it provides agility and flexibility, is going to kill you in terms of team consistency and mobility of skills and rebuilding the wheel every time. Centralize on languages, centralize on how you package. Nobody should be doing anything except for container images at this point. It's just, there's no point. Use container. You don't have to use Kubernetes, but use container images. It's just, this is a problem that nobody wanted to solve, and it's a solved problem at this point. Similarly with container registries, pushing images around the world. Got to centralize continuous testing and delivery, in part because the people who are excited about this sort of stuff are few and far between. So you're barely going to be able to build one team that is excited about build and test. So make sure that team can be scaled out to your entire organization. Those 4 people who are excited about test can go and do their thing, but that their skills can translate to every single team. This is centralized infrastructure that you need. Similarly with monitoring, logging, and alerting, every single team needs to be using the same monitoring system so that you can cross-correlate, so that you can visualize, the same alerting system so that you can do handoffs. There is all of these places where even when we're doing microservices, we have to have a consistency there. We have to have a uniformity, or else we really are 100 different teams. We're not, sub-teams working towards a common goal. I think one of the other sort of places where people don't focus enough time initially is on building shared API and RPC infrastructure. Even something as simple as certificate rotation becomes dramatically easier if everybody's using the same RPC library, and becomes a very, very hard problem if everybody's kind of rolled their own HTTP server. So this is something where if you don't get it right at the beginning, It's very, very hard to retrofit. It just pays dividends over and over and over again. So whenever you're starting out on a new project, make absolutely certain that you standardize on RPC infrastructure, whether you write it yourself, whether you take something off the shelf like gRPC. It doesn't really matter, but consistency here is crucial. Similarly with sort of the crown jewels of identity, authorization, and secrets, if you don't have a central place where all of this stuff is managed, audited, you're going to be in a world of hurt, right? If everybody uses a different identity system, certificates versus tokens versus whatever else, you're going to be in a ton of pain. So this is core infrastructure that you have to, again, identify at the beginning, make sure is consistent across all of those different heterogeneous microservices. And it's easiest actually if it's deeply integrated into the RPC layer. Storage is another one, like continuous testing, where the number of people who can successfully run storage at scale is not that large, and it makes sense to turn it into a team. So you don't want every team running their own database. If you're in the cloud, it makes sense to buy it as a service, let someone else have that problem. If you're running on premise, you need to find a storage team, build a storage team, and not allow heterogeneity. You don't want one team using SQL Server and another team using MySQL and another team using Postgres and another team using Mongo and another team using Cassandra and some other team using text files. Storage is hard enough to get right when there's one protocol and when there's one database engine. If you have 20 different ones, you don't stand a chance, right? So even if people really, really, really think that NoSQL is the hippest possible thing that they can do, if 85% of your company is using SQL Server, everybody should be using SQL Server. Similarly with MySQL or Postgres or whatever else. You have to standardize on storage. In the cloud, it becomes a little bit easier, but even so, experience in profiling, performance, all of the sort of aspects of system design and debugging become easier if you have only one engine that people need to become familiar with. I think another important piece of cross-cutting infrastructure is this idea of analytics and experiments. You have to understand how your system is being used by the end users. You have to have the ability to do experiments and A/B testing to move forward. This is hard stuff to get right, and it's not stuff that most developers think about. So making it available as a service, even just the ability to do flag flips as a service, or 2% cookie-based experiments. This is something your developers aren't going to build for themselves, but is essential for the business. And so create it as a service for you at the beginning. All right. Hopefully I don't have a watch on me, so I hope that was not, I'm roughly speaking on time. I really think that when we think about microservices, if we think about the technology, we are thinking about it wrong. We want to be thinking about teams, about how we scale our teams, how we build happy, well-performing, efficient teams. Because at the end of the day, if we do that, the technology choices become obvious. And if we do that, building a product becomes easier. And for all of those things that we care about, from the product to the user to the team, we're going to do a good job. Hopefully this has given you an idea about why microservices are important, but what some of the challenges are as you think about building teams, building services with microservices. And with that, I want to end with a few things. Focus on scaling your team, not your service. Think in APIs. Really focus on the API layer. This is like the object-oriented design of the early 80s or mid 80s. Instead of thinking about objects, think in APIs. Empower individuals and individual teams. The best ideas, and I see this over and over and over again, the best ideas are going to come from the people on the ground. And so the more you can empower people, the more you can empower teams, the better your ideas will be. Kind of scary as a leader. It's a little scary to do that, but it has paid dividends for me more times than I can count. But also at the same time, identify those teams to build shared infrastructure so that you can rely on it and everybody can have access to the same consistent stuff like monitoring and the experiments and everything else we've talked through. And with that, I want to say thank you. I really appreciate the opportunity, and we will open it up for some questions. And I'm going to drop the screen share and see how I did on time. So thank you so much.
Thanks, Brendan. Thanks a lot. We have a couple of questions as of now in the chat, but I would also request the attendees, they can unmute themselves and ask the questions. Now it's okay to ask the questions on the in the voice mode. So the first question in the chat is, would you mind to share slides afterwards?
Sure. I don't know where I can. Nilesh, if I just send them to you, can you share them somewhere?
Yes, I can do that.
Perfect.
Yeah. The next one is, will the microservices increase the overall software license cost as the services are created in different technology and tools by each member in the team?
Yeah, it can. I mean, and that's where I sort of was mentioning about how there's this trade-off between agility and empowerment and standardization. And so, I think it is important to consider, I mean, the cost of a choice. And sometimes you do have to standardize, right? So sometimes you're going to come along and say, hey, look, we're going to use Linux and MySQL because they're both open and they're both free. And we know you love Windows or we know you love SQL Server, but those choices are off the table. So I think there is a degree to which a company or a product has to make some rules up front and accept that it's going to disappoint some people. But also at the same time to maintain flexibility in the right places, so that teams can make the choices that are right for them.
Okay. There is a suggestion to have a follow-up session on getting deep dive into some concepts like authorization, authentication, and storage. Thanks for this suggestion, Gaurav. We will look into it. We will organize some follow-up sessions on these topics as part of our regular user group activities.
Yeah, absolutely. I think those kind of tutorials can be great to sort of hand on.
Yeah. Then there is a question from Ansari. Do we need to put all microservices behind APIM layer, even if they are deployed in the same AKS cluster?
I don't think you necessarily have to put it behind an APIM layer. I think it is good, though, to make sure that you're doing authorization and authentication and rate limiting. And so if the easiest way to do that is to use something like APIM, that can be useful. There's also a bunch of open source projects out there like the Kong and others that can provide API gateways that run inside the Kubernetes cluster. And at the end of the day, I don't think, I don't know that APIM is required, but you definitely want to have some sort of, even if it's just an SDK, even if it's just a shared library that everybody uses for their web server and for their clients, you do want to have shared API infrastructure. So it's going to kind of depend on your specific team and obviously cost also, what you choose. But having something there is critical.
Okay, there is a question on the YouTube stream from Puneet. He is asking, how do you see microservices with or without Kubernetes in multi-cloud environments?
Yeah, I think this is one of the interesting challenges. I think there's a bunch of great tech like OpenAPI for specifying APIs so that you can generate clients that work in multiple different environments. I think they're still pretty open. I think people, when they build in multi-cloud, they tend to build silos. So they'll tend to build a complete stack and then put it load balance, have a complete stack in Azure and a complete stack on premise, and then put a load balancer between them, and then maybe do some data replication at the bottom, rather than doing, a lot of APIs back and forth between the clouds. And that's partially because of things like, ingress and egress bandwidth costs. But I think with Kubernetes, we are seeing people more and more be able to deliver these APIs in sort of the same format everywhere. And so as a result, people are starting to explore with how do I actually, do bursting into the cloud? How do I run mostly on-prem, but burst into the cloud if I'm under heavy load or things like that? So I think it's an area that's going to be explored more in the coming years.
Okay. There is another question here in the chat from Ansari. He's asking, we are starting with AKS and wanted to use service mesh concept. We are struggling with the options like console or Istio. Any suggestions?
Well, we did actually just recently open source a project called OSM, the Open Service Mesh. It's a simpler service mesh. It's intended to be easier to use, easier to adopt, lighter weight. So you might check that out. It's still in very active development. Um, I wouldn't necessarily immediately go to production with it. Um, but I think the other thing to think about though is even do you need a service mesh, right? I think many people kind of check the box. I was talked a lot earlier about, us adopting technology for technology's sake. I think sometimes people check the service mesh box just because it was there, on the checklist rather than because they actually really need it. And so I would think about like if you are building a shared RPC layer and you have certificates for encryption, maybe that's enough, right? If you're using experiments layer out of the outside and you can do, experiment routing, maybe that's enough, right? So I don't, I think that sometimes we overcomplicate things. So I definitely encourage you to focus on sort of what your needs are. But if service mesh is what you really need, I think we're Microsoft is very actively developing the open service mesh, which is based on Envoy, and so that's where our energy is going.
Okay. I had a question, Brendan. You talked in terms of implementing some of the best practices, and there was one around deprecating the services or your APIs. So, if you look at the mainstream programming languages, we have some of the tools which can automatically enforce things, or they can at least highlight, right? Like things like Sonar Cloud or something which can scan your code base and give you recommendations or flags saying this is not in line with the principle. Are there any tools or anything available when it comes to APIs and microservices which can validate these kind of things and enforce or help you to enforce things?
Um, it's not great, I would say. There's a little bit. So if you look at the Open API specification, there is the ability to mark things as deprecated and things like that. I think generally speaking, what people do is they change the version number. So unlike, you know, um, maybe a Java or something like that, where people kind of don't. I mean, they do think about like Java 7, Java 8, whatever, but they don't necessarily think too much about it until APIs get deprecated. It as part of a library or something like that. I think with formal REST-based APIs, you tend to specify the API version as part of the API request, and so you can definitely look at those logs and flag. But I mean, I would say even Azure doesn't do a great job of this today. I'm actually working with the Azure teams right now to try and send messages to people who use old clients and old API versions because we don't do a really good job notifying people when they're using old APIs, and we've seen people have problems, right? Because they're using an API from 5 years ago. It's not deprecated, but it's just not the newest, most efficient API.
Yeah.
Yeah. So
Okay.
that's definitely a challenge. That's programming languages have done it much better.
Okay. That's all we have in the questions in the chat. Anybody wants to ask a question over the Teams channel or using your by unmuting yourself? Okay. If there are no questions, then I think we can close this session here. Thanks a lot. Thanks, Brandon, for taking time out of your busy schedule. I know it's a bit late for you. It's already maybe 9 or close to 10 your time.
Nine
So
o'clock. Yeah,
yeah, really
it's
appreciate this. Thanks
it's
a
time
lot
to go do
for.
kids' bedtime. So I appreciate it as well. I really, it was great to chat with you. And please, if there are any future questions, please feel free to, reach out to me on Twitter or anywhere else. And hopefully we'll all meet up in person someday.
Yeah, I was just about to say that.
Yes,
Thank
indeed.
you.
All right, take care.
Thanks.
Bye.
Bye bye.